Out of the mountain of despair, a stone of hope is sufficient for a victory. Hi everyone. In this video, we'll go through problems related to partial fractions where you have certain non-linear equations. You have to convert them to linear equations before resolving into partial fractions. Now, if you observe this particular function, you have an equation in the numerator, an equation in the denominator, right? So this is a rational function. This is a rational function. Now, you can express this particular rational function in simple forms, in simple fractions, using simple fractions. And these simple fractions are called as partial fractions. Now, for example, I can take this particular rational function and can represent it as 3 by x plus 1 plus 2 by x minus 2. So this entire rational function can be expressed as sum of two simple fractions. This is one simple fraction, this is one simple fraction, right? So adding both of these simple fractions, I get this particular rational function. So these fractions are also called as partial fractions. This is called as partial fractions. Now basically, when we are asked to resolve, when we are given a rational function like this and we are asked to resolve using partial fractions, then we basically have to split. We have to split this entire rational function into multiple simple fractions or partial fractions. Degree of an equation, right? What is degree of an equation? Degree of an equation is the highest power of x or a variable. So now in this particular rational function, which is the variable? X is the variable, right? So what is the power of this particular x? There is nothing here, right? Which means the power is 1. So if you look at this entire equation, what is the highest power? It's 1. So degree is 1. We call degree of numerator is equal to 1. Now look at this denominator. You have two equations here. So when I multiply these two equations, what do I get? I get x into x is x square, x into 1 is x, minus 2 into x is minus 2x, minus 2 into 1 is minus 2. I further simplify it. I'll get x square, x minus 2x is minus x, and then I have minus 2. Now you look at the degree. The degree of x is, you have, what are the powers? What are the powers of this particular equation? You have 2, 1, right? This one is 2. There is nothing here, which means power is 1. Now, what is the greatest power here? It is 2. Therefore, we call degree of denominator equation is 2. So, numerator degree is 1. Denominator degree is 2, right? You don't have to multiply this every time to find the power. Here, you can take x and simply multiply only x and x. If I multiply x and x, I'll get x square, correct? So this becomes the degree, right? Now, if I had something like this, say like this, if I had an expression like this, now what is the degree for this? What is the degree for this? Here, simple. If I multiply this x with this x, I'll get x square, right? And then again, x square I multiply with this x. So I'll get x cube. So what is the degree? It's the highest power. What is the highest power? 3. Right? This way we find the degree of the equation. So degree of an equation is highest power of x. Now it could be any variable. It could be x or y or z, right? Any variable or any unknown in an equation. Now before we solve partial fraction problems, we'll have to understand what is a proper fraction and what is a improper fraction. Now what is a proper fraction? You first find the degree of numerator and degree of denominator. Now what is the degree of numerator? It is the highest power. So what is the degree here? It's 1, right? Because x has no power, which indicates it's 1. And here when I multiply x and x, I'll get x square. So the degree is 2. Now if you see, numerator degree is 1 and denominator degree is 2. So degree of numerator is less than degree of denominator. So therefore, this is called as a proper fraction. This function or this fraction is called as proper fraction because degree of numerator is less than degree of denominator. Now let's see what improper fraction is. In case of improper fractions, degree of numerator will be greater than or it can be equal to degree of denominator. Now take this example. What is the degree of numerator here? It is 2, because the highest power of x is 2. And what is the degree of denominator here? It is 2. Right? So degree of numerator is equal to degree of denominator. So this is improper. Now let's take another example. 5x cube minus 4 by x plus 1 into x minus 2. Now in this example, what is the degree of numerator here? The highest power is 3. So degree is 3. And here in denominator it is 2. So numerator degree is greater than denominator degree. Correct? So this is an improper fraction. This is an improper fraction. Now, how do we simplify this? What is the method? So what we do is, we take this denominator terms, right? You have, this is one term and this is second term, right? Second equation basically. What we will do is, we will take the denominator like this. One denominator, that is one fraction. Let's call this as first fraction, second fraction. In the first fraction, you will put the denominator as x plus 1. In the second fraction, you will put the denominator as x minus 2. And then you add in between, right? Now, we don't know the numerator, right? We don't know the numerator. So what we will do, we'll assume it is a and b, right? Finally, when we solve this entire rational function into partial fractions, it should be in this form, right? But we don't know the value of a and b. Now, instead of a, you could have 3. It could be 3 by x plus 1. Instead of b, we could have 2 by x minus 2. Now, these could be the partial fractions for this entire rational function. But we need to obtain this 3 and 2, right? So, we assume, right? As a first step, we assume that the numerator would be a and b. Actually, if I cross multiply this, I'll get 3 into x minus 2 plus 2 into x plus 1 by put both the denominators, right? I'm cross multiplying. I'm multiplying 3 with this expression and 2 with this expression. 2 into x plus 1 and 3 into x minus 2. And then I put both the denominators here. So what will happen? I'll get 3x, 3 into x and 3 into 2 minus 6 plus, now I'll multiply. 2 into x is 2x, 2 into 1 is 2, right? Divided by x plus 1 into x minus 2. This is x minus 2. So when I simplify, what do I get? 3x minus 6 plus 2x plus 2 by x plus 1 into x minus 2. Now I can add minus 6 with 2 and 3x with 2x. 3x plus 2x is 5x. Minus 6 plus 2 is minus 4 by the denominator. Now, you see, when I simplify these partial fractions, I'll get back the original rational function. Is it not? This function, this rational function, I'm getting when I use the simple fractions and multiply the simple fractions. So when I use the simple fractions and add the simple fractions, I will get the original rational function, right? So this is what we have to find out now. We'll have to find these simple fractions. We need to represent this entire rational function into simple partial fractions. Now let's take an example and resolve this into partial fraction. Resolve into partial fractions. So what is the first step? What we will do is, we'll put this, copy this as is, right? First, we need to check if it's proper or improper. Now, find the degree. What is the degree of numerator? It's 1. What is the degree of denominator? X into x square. So, degree of denominator is 2. So, here numerator degree is less than denominator degree, which means this is proper fraction. This is proper fraction. Now, what we will do, next step is, once we have checked that it's proper fraction, we need to split it. We need to split this entire function like this, right? A and B, and we put the denominator. So, first one we'll put as x minus 2. Second one we'll put as x plus 3. Now, you have two methods to simplify this, right? First one is, you can you can use LCM method, or second one is you can multiply the denominators. You can multiply the denominators on both sides like this. So you take this denominator. What is the denominator? X minus 2 and x plus 3. You multiply this x minus 2 and x plus 3 on both the sides like this. So we'll take x plus 1. You multiply with this denominator, x minus 2 into x plus 3. Then you copy everything as is. Now here what we will do, we'll take a and multiply both these denominators, x minus 2 into x plus 3 plus b into, again both the denominators, x minus 2 into x plus 3. Let's not forget to put the denominator, x minus 2, and for b we have x plus 3 as the denominator. Now what we will do, we'll cancel the common terms, x minus 2, x minus 2, x plus 3, x plus 3. Here you have both the terms as common, you're cancelling it. So what do we get? We get x plus 1 here, and this is equal to a into x plus 3 plus b into x minus 2. This is equation, let's call as equation 2, and let's call this as equation 1, right? Let's call this as equation 1 and let's call this as equation 2. So first step is when you split it, you call this as equation 1. Second step is when you get an expression like this where you have removed the denominators. Basically, by doing this particular step, you will remove the denominators itself. Now what I will do is, as a next step, I will have to take the values of x, right? Now here I have x plus 3. So I will put x as opposite sign, minus 3. Here I have plus 3. I will say x is equal to minus 3. First one. Second one, here I have x minus 2. So it's minus 2. I will say equal to plus 2. Now I'll take these two values of x, right, and substitute in this equation 2. First I'll take this value of x, substitute it here. Then I'll take this value of x, substitute in this particular equation. Why I will substitute is, I will get the value of a and b. Our ultimate goal is to find the value of a and b. If we find the value of a and b, that means we have resolved this into partial fractions. So now, to find the value of a and b, we are substituting the value of x. Let's take case 1, right? Case 1 is put x is equal to minus 3. X is equal to minus 3 in equation 2. So what is equation 2? Let's copy it down. I'll put x is equal to minus 3. So instead of x, I'll put minus 3 plus 1 is equal to a into minus 3 plus 3. Instead of x, I'm putting minus 3. So I'll simplify. So minus 3 plus 3 will become 0. So I'll get 0 into a plus minus 5 minus 5b. So 0 is, you can ignore, it becomes 0. Plus and minus is minus. So minus 5b. And here it's minus 3 plus 1 is minus 2. I'll find the value of b. This is nothing but minus 5b is equal to minus 2. I'm just shifting it, right? So I'll get minus 5b as minus 2, which means minus and minus will get cancelled. I'll get 5b is equal to 2. Therefore, what is b? B is, I'm shifting this 5 this side. This is 5 into b. So when I shift, it will become division. So it will become division. So it will be 2 by 5, right? This 5 is at the top. When I shift, it will come to the bottom. That is in the denominator. So it will be 2 by 5. So b is nothing but 2 by 5. So I got value of b. Now what should I do next? I need to find the value of a. Now I'll take the value of x is equal to 2. The second case, right? The second case, I'll take value of x and put in this equation 2. Put x is equal to 2 in equation 2. Now let's copy the equation. Let's substitute value of x in this equation. So what I'll get? X is equal to 2. So it will be 2 plus 1. A into, instead of x I'm putting 2. So it will be 2 plus 3. Plus b into, instead of x I'm putting 2. So it will be 2 minus 2. So 2 minus 2 will be 0. 0 into b is 0. Right? I'll get 0 here. And this will be 5a. And this will be 3. Now I know 5a is equal to 3. Therefore, a is what? A will be 3 by 5. Basically, 5a is equal to 3, which means a is equal to, I'm shifting 5 this side. So it will become 3 divided by 5. So this is value of A. So now we got value of A also. We got value of B also. What is the next step? The last step, we take this equation 1 and substitute values of A and B, right? Now let's take this entire equation 1 and substitute values of A and B. So A is 3 by 5. So I'll put 3 by 5 and we have to put the denominator also. Denominator is x minus 2. Now what is the value of B? 2 by 5. So I'll put 2 by 5 and the denominator is x plus 3. So this is nothing but partial fraction. So now whatever answer I've got, right, I can verify if this answer is correct. How do I verify? I can cross multiply here and simplify this. I should get this function back. So let's try it out, right? This is just to verify if your answer is correct. So what we will do, we'll cross multiply. So I'll cross multiply this 3 with this entire term. So into 5 into x plus 3. I'm going to multiply. Then here again I'll cross multiply. 2 into 5 into x minus 2. And then I'm going to multiply both these denominators. 5 into x minus 2 and 5 into x plus 3. Now I'll simplify, right? So 3 into 5 is 15, right? 15 into x plus 3. I'll first multiply the numbers. 2 5s are 10. 10 into x minus 2 by, now let me multiply the numbers. So I'll get 25. Then I'll get x minus 2 into x plus 3. Now let's further simplify. So 15 into x is 15x. 15 into 3 is 45. Then 10 into x is 10x. 10 into minus 2 is minus 20. I'll just copy the denominator as is. Right? We don't have to multiply this. We'll leave it here. Now 15x plus 10x is, we'll add the similar terms. 15x plus 10x is 25x. 45 minus 20 is plus 25. Divide by 25 into x minus 2, x plus 3. I don't want to multiply the denominators, only the numerators will simplify. Now I can take 25 as common, right? If I take 25 as common, I'll be left with x. So since I've taken 25 as common, I'll be left with 1 here. I'll get 25 into x minus 2 into x plus 3. I can cancel 25 and 25. So what I'll be left with? X plus 1 by x minus 2 into x plus 3. Now observe, this is the original function. Both are same, right? So we have verified that the answer that we got is correct. Now let's take another example. Now in this example, we have the denominator like this, right? It's a quadratic equation. What is it? It's a quadratic equation. What is quadratic equation? Equation which has power 2. That is, it's of the form ax square plus bx plus c. It's of this form, right? X square minus 6x plus 8. So you basically have x square, you have x, and you have constant or just the number. It's of the form ax square plus bx plus c. So you have x square, you have x, and then you have only number, right? This is a quadratic equation. Now, whenever we are resolving into partial fractions, we cannot have quadratic equation. We have to represent it in the form of linear equations, right? We cannot have quadratic equation or any expression with power as more than 1. Now you see power is 2. We cannot have power as 2. So we have to simplify this in the form of linear equation. What is a linear equation? It is of this form, ax plus b, right? This is a linear equation. So if you notice, x plus 1, x plus 2, all these are linear equations. Basically, x will have only power which is equal to 1, right? It will only have power which is equal to 1, right? There's nothing here, it means power is 1. X plus 1, x plus 2, x plus 5 plus 6. So these are all linear equations, right? So now we'll have to represent this entire equation in the form of linear equation. How do we do that, right? Let's solve this. We will have to factorize. Right? What is the sum? 3x plus 1 by x square minus 6x plus 8. Right? Now we will have to factorize this. Factors means you want to bring it into the form of linear equations. Right? Like x plus 1 into x plus 2. Like this we want to represent. like the first example, right? If you notice the first example, right, this is linear equations. We have to put the denominator in this form. So now there are three methods to factorize: sum product, then you have formula, then you have direct method of getting the factors, direct method of getting factors. We'll go through formula method here. In the next set of problems, we'll go through sum product and direct method, right? Here in this problem, we'll use formula method. Now, what is the formula? You have to by heart this formula. Formula is minus b plus or minus root of b square minus 4ac by 2a. This is the formula. Now, what is this a, b and c? A, b and c are coefficients of x, right? Basically, a is coefficient of x square, b is coefficient of x, c is constant or number only, number without x. Now, if I take this particular equation, x square minus 6x plus 8, what is the coefficient? Number next to x. Number next to x. Now you have x square. You don't have any number here. When you don't have any number, you assume there is 1. So 1 is the coefficient. So here a becomes 1. A becomes 1. And b is coefficient of x. What is the number next to x? It is 6. We'll have to put the sign also. It is minus 6. Minus 6. So we'll have to put as minus 6. Constant. Constant means this one. It's just a number, right? There is no x in this, right? So this is constant. This is nothing but plus 8. Now we will substitute this a, b, c values in this formula and get the values of x. We'll basically get the values of x. I'll put x is equal to minus b. What is b here? Minus 6. We already have minus here. And then b is minus 6. So minus of minus 6 plus or minus, you have to put this plus or minus root of b square. What is b? Minus 6 whole square minus 4 into what is a? 1. What is c? 8. Divide by 2a. 2 into a. A is 1. Now we'll simplify this. So minus into minus is plus. So 6 plus or minus 6 square is 36 minus 32 by 2. Now this will be 6 plus or minus 36 minus 32 is 4 by 2. Now we'll have to split this. That is, you have to write this as 6 plus root 4 by 2 and 6 minus root 4 by 2. That is, you take this entire expression with plus and then with minus, with plus and then with minus. So now we'll get two values of x. Put a comma here. This is one value of x and this is another value of x. So this will become root of 4 is 2, right? Root of 4 is 2. So it will be 6 plus 2 by 2. This will be 6 minus 2 by 2. So I'll get 6 plus 2 by 2 is 8 by 2. 8 by 2 is 4. 6 minus 2 is 4. 4 by 2 is 2. So these are the two values of x. What are the values of x? 4 and 2. Now I should write it in the form of linear equation. How should the linear equation be? It should be like this: x plus 1, x minus 2, x plus 4. In this form it should be ax plus b is equal to 0. This is how we represent linear equation, ax plus b. Now we have two values of x, right? 4 and 2. So what we'll do, the values of x is equal to 4 and another value of x is equal to 2. Now we'll have to write this as x minus 4. I shift 4 this side, what will happen? This is plus 4. When I shift, it will become minus 4. Here again, when I shift 2 here, what will happen? It will become x minus 2. So these are the two linear equations. So this entire denominator that we had, we'll have to write it as 3x plus 1 by x minus 4 into x minus 2. So now you see, we have converted this quadratic equation into linear equation, right? Now we'll go with the step where we have to split this. How we will split? We have two terms here, right? in the denominator. First observe how many terms we have in the denominator. Basically, how many equations. This is one equation, this is second equation. So I'll have two variables, a and b, right? And then I add it, a and b. Then now I put the denominator. First one is x minus 4. Second one is x minus 2, right? We can put it like this. Now you can put this as b or you can put this as a. The order doesn't matter, but you just have to find the values of a and b and put these denominators. Then only it becomes a partial fraction. So now we can solve this problem. There are two methods here, right? To simplify, you can cross multiply the denominators. Cross multiply the denominators, or you can take LCM method, right? Let me go with cross multiplication. LCM method is simpler actually, but let's go with cross multiplication. We'll go with LCM method in the next set of problems, right? Now here I'll cross multiply. So what are the denominators? These two are the denominators. So I'll multiply a with both the denominators, x minus 4 into x minus 2, plus b with, again same thing, x minus 4 into x minus 2. And what will happen to the denominator here? I'll have, here I have x minus 4. For b I have x minus 2. Now on the left hand side also have to do the same thing. So I have 3x plus 1 by x minus 4 by x minus 2. Don't put this, put this, right? These linear equations. Now I have to cross multiply here also, right? With these denominators, x minus 4 and x minus 2. So I have taken both these denominators and multiplied here. Now what will happen? This and this will get cancelled. This and this will get cancelled. Here x minus 4 and x minus 4. Here x minus 2 and x minus 2. So basically I have removed the entire denominator. Now there are no denominators at all. So I will rewrite this. I'll write it as 3x plus 1 is equal to a into x minus 2 plus b into x minus 4. Now we call this as equation. Let's not forget, we call this as equation 2. And this is equation 1. Let's not forget, this is equation 1. This is equation 1. Finally, once we find the value of a and b, we have to substitute the value of a and b in this equation. Now, what is the next step? We have to substitute, right? What do we have to substitute? X. Now, how do we know the values of x? Simple. Here you have x minus 2. So we'll put opposite sign. It's minus 2, we'll put plus 2. This is one value. Second value of x here. Here you have minus 4. We'll take the opposite sign, plus 4. So first time we'll substitute with 2. Second time we'll substitute with 4. We'll get the value of a. We'll get the value of b. And then put those values in equation 1. Let's solve it, right? So put x is equal to 2. Again, order doesn't matter. You can put x as 4 first or x as 2 first. Order doesn't matter. So I'll put x is equal to 2. So I'll get 3 into 2 plus 1 is equal to a into 2 minus 2 plus b into, instead of x I'm putting 2. So it will be 2 minus 4. I'll get 0 into a, which is 0, plus 2 minus 4 is minus. 2 minus 4 is minus. So I'll remove this plus. I'll put minus 2b. Here it is 6 plus 1, which is 7. Now I'll find the value of b. What will be b here? B will be 7 by 2 and minus. 7 by minus 2, right? B will be 7 by minus 2, which is nothing but minus 7 by 2. This is the value of b. Now we'll find value of a, right? So for that we'll put x is equal to 4. So let's take that equation, copy paste this equation, and instead of x I'll put 4 plus 1 is equal to a into, instead of x I'll put 4 minus 2 plus b into 4 minus 4. So this will become 0. This will become 4 minus 2 is 2, 2 into a. This will be 3 4s are 12, 12 plus 1 is 13. Therefore what is a? A is equal to 13. I'll bring down 2 because this is multiplication. When I shift it to the other side, it will become division. So it will become 13 by 2. So a is 13 by 2. So we got the value of a also. Now we go to the final step. We take this equation, right? We take this equation. What do we have for a? 13 by 2. 13 by 2 into x minus 4. And what do we have for b? Minus 7 by 2. It's minus, so we'll put minus 7 by 2. Let's copy the denominator, which is x minus 2. This is the set of partial fractions now. So these are the partial fractions for this particular rational function. Now let's take another problem, slightly more complex. Here we have both linear equation and quadratic equation in the denominator. So let's solve this. But let's remember, every time before starting the problem, you will have to figure out if it is a proper fraction or improper fraction. So we'll have to look at the degree of the numerator and degree of the denominator equations and then determine if it is proper or improper. Degree is nothing but power of x, right? Here the power of x is 2. Here the power of x is 1, right? Here there is no x. So, but the highest power of numerator, what is the highest power of numerator? 2. So this 2 is the degree of numerator. So I would call this as numerator and this is denominator. Now what is the power here? When you multiply this denominator with this particular term and this particular term, you are going to get x cube, is it not? X square into x is x cube. Then what is the power? Power is 3. Now you see that the degree of numerator is less than degree of denominator. Hence this is a proper fraction. Now we'll have to split this into partial fractions. We have this quadratic equation here, right? First we need to factorize these equations. It has to come in this form, like x plus 1 or x plus 2. There are multiple ways to factorize: sum product method, formula method, direct method, right? Now if it is simple problems, we can factorize it directly. If it is slightly complex, then we might have to use formula method, and for some problems we can use sum product method based on the complexity of it. Now here we have this particular quadratic equation. We can use formula method. This is the formula: minus b plus or minus b square minus 4ac by 2a, right? A, b, c are the coefficients. What are coefficients? Coefficients are nothing but numbers which are next to x. So for example, in this case, the number next to x square is 1. So a is equal to 1. Number next to x is minus 5. So b is equal to minus 5. And then we have constant, which is simply the number without x. And here c is equal to 6. So in this case, a is equal to 1, b is equal to minus 5, c is equal to 6. So we'll have to take the signs also. Take these coefficients, substitute in this formula, and then you'll get two values of x. One is when you add, when you use plus, and the other one is when you use subtraction, right? So you'll get two values, 3 and 2. The way we have to write these factors is, here we have got directly x values. So we've got x is equal to 3 and x is equal to 2. So we'll have to write this as x minus 3, x minus 2. Why? Because when x is equal to 3, if I shift 3 to this side, I'll get x minus 3 is equal to 0. And when I shift 2 this side, I'll get x minus 2 is equal to 0. So the factors are x minus 3 and x minus 2. The other method is sum product, right? Here you'll have to choose two numbers in sum product. So minus 5x plus 6, x square minus 5x plus 6. Choose two numbers such a way that this is the sum and this becomes the product, right? So now sum has to be minus 5. So you have to choose two numbers, number 1, number 2. And when you add these two numbers, you should get minus 5. And when you multiply these numbers, you have to get 6. So we can take 3 and 2, because when we multiply in 3 and 2, we'll get 6. And when we add 3 and 2, we'll get 5. But we'll have to get minus 5. That means both of these numbers should have minus, because when you add minus 3 and minus 2, you're going to get minus 5. And when you multiply minus 3 and minus 2, you're going to get plus 6. So here we get minus 3 and minus 2. The way we'll have to write this is x minus 3 and x minus 2. This is how we'll have to write. Direct method. How would I do it in the direct method? This is like this, right? I'll have to split. This is direct method. Split minus 5x into two terms. So I can write it as 5x can be written as 3x and 2x. I can write it as 3x and 2x. Since there is minus 5x, I'll have to write it like this, right? I can write this as minus 3x and minus 2x. So when I add these two, it's going to be minus 5x, right? This is another way. Now here I'll take common factor. Here between these two, I can take x as common. So I'll get x minus 3. And between these two, I can take 2 as common. I'll take minus 2 as common. So I'll get x. Since minus has been taken out, this will become minus. Plus will become minus. And 2 3s are. So I'll get this. Now if you notice, again here x minus 3 is common. So I'll get x minus 2. So the factors are x minus 3 and x minus 2. So there are multiple methods. 3 methods I have already mentioned. So you may need to practice all of these methods to arrive at the factors. And this is very important for resolving partial fractions related problems. So from all 3 methods, we know that the factor is x minus 3 and x minus 2. So now we'll write this as x square minus 10x plus 13 by x plus 1. We can write this as x minus 3 and x minus 2. This is equal to, we'll write a by, we'll take this one, x plus 1 plus b by this one, x minus 3 plus c by x minus 2. This one. So we've splitted these 3 denominator terms to 3 separate terms. We can take LCM, or you can multiply on both the sides by the denominator, right? Again, there are 2 methods. You can either use LCM or multiply on both the sides by denominator. If I multiply both the sides by the denominator, that is like this, x square minus 10x plus 30 into x plus 1, x minus 3, x minus 2. So I'll multiply both the sides with the denominator terms. So I'll get this, then divided by x plus 1, then plus b by x minus 3 into all the denominator terms, plus c into all denominator terms by x minus 2. Now if you notice, you can cancel x plus 1, x plus 1, x minus 3, x minus 3, x minus 2, x minus 2, and here we have this denominator already on the left hand side. So here all these terms will get cancelled. So we'll be left with x square minus 10x plus 13 is equal to a into x minus 3 into x minus 2 plus b into x plus 1 into x minus 2 plus c into x plus 1 into x minus 3. So basically, other than this term, these 2 terms will get associated with a. For b, other than this term, these 2 terms will get associated with b, right? Now in this equation, we'll take values of x. We'll take x is equal to 3. We have x minus 3, so we'll take the opposite sign, x is equal to 3. Here we have x minus 2, so we'll take x is equal to 2. Here we have plus 1, so x is equal to minus 1. Now using these 3 values of x, we'll substitute all these values of x in this equation one by one and get values of a, b and c, right? Now let's substitute first one with x is equal to 3. You will get 3 square minus 10 into 3 plus 13 is equal to a into 0, because 3 minus 3 is 0, and 3 minus 2, plus b into 3 plus 1, 3 minus 2, plus c into 3 plus 1, 3 minus 3, right? Now there is, since 0 here, this will become 0, plus b, 4b and 1, you get 4b plus 4, this is 0, this will become 0, right? And here we are going to get 9 minus 30, 9 minus 30 plus 13, you will get minus 8 is equal to 4b, which means b is equal to minus 8 by 4. So we get b is equal to minus 2. Now we'll find the second one. Now we'll take the second term, which is x minus 2. Now we'll assume x is equal to 2. So let x is equal to 2. Now take 2 and substitute in this entire equation, 1. So we'll get 2 square minus 10 into 2 plus 13 is equal to a into 2 minus 3, 2 minus 2, which is 0, plus b into 2 plus 1 into 2 minus 2 plus c into 2 plus 1 into 2 minus 3. So on solving this, we'll get 4 minus 20 plus 13, we'll get 0. This will be 3, this will be 0, minus 3c. This will be 3 and this will be minus 1. So minus 3c. And this is minus 3. Minus 3 is minus 3c. This is nothing but c is equal to minus 3 by minus 3. C is equal to 1. So now we have got the values of b and c. Now we will have to find the value of a, right? We have taken x is equal to, we have finished x is equal to 3 and x is equal to 2. Now we'll have to take x is equal to minus 1, right? So let's take x is equal to minus 1 and substitute in this equation. So on substituting x is equal to minus 1, we will get this particular expression. So on simplification, we'll get 12a is equal to 24. Thereby, we'll get a is equal to 2. Now that we have got all the values of a, b and c, we'll take the original expression where we had split it in terms of a, b and c and substitute the values of a, b and c. So on substituting, we'll get a is equal to 2, 2 by x plus 1, b is equal to minus 2, minus 2 by x minus 3, c is equal to 1 plus 1 by x minus 2. So here we have got the partial fraction. Now let's take this next problem. We'll always have to check if it's proper or improper fraction. So let's get the degree of numerator. Degree of numerator is highest power, right? The highest power becomes the degree. Now the highest power of x. What is the power of x here? There's nothing, which means it's 1, right? So degree is 1. Here highest power is 2, right? And here power is 1, which is highest power 2. So this becomes a degree. Now this is a proper fraction because here the degree of numerator, which is 1, is less than degree of denominator, which is 2. Therefore this is a proper fraction. So now we'll go with splitting the fractions. So we'll have to split this, right? Now before splitting, we'll have to see that it should be in linear equation form. The denominator terms should be in the form of linear equations. What are linear equations? In the form of ax plus b. Something like 2x plus 1 or x plus 3, x plus 4, whatever. X should have power 1 only. You cannot have x square or x cube or x to the 4. You can't have it. You should only have x with power 1. That is what is called as linear. X to the power 1 is called as linear equation, like this. Now here if you see, you have x square. So we'll have to simplify this. How we can simplify? One is, we can take x as common here. If I take x as common here, right? Between x square and 4x, x is common, right? So when I say common factor, what does it mean? I have to divide this entire thing by x. If I divide this by x and this by x, what will happen? X square is x into x. If I divide by x, 1x and x will get cancelled. So I'll be left with x, right? X. And now when I divide 4x by x, x and x will get cancelled. I'll be left with 4. Right? This is what is called as common factor. So now I've got it in linear equation form. The power of x is only 1. So what I will do is, I'll write this as 3x plus 20 x plus 4. Now I'll split it as How many denominator terms I have? 2. So I'll have 2 fractions. Add them. One denominator will be x, other denominator will be x plus 4. I can use LCM method or I can cross multiply, right? LCM method is always better. It reduces the number of steps. Now LCM method is simple, right? I take x and x plus 4, both the denominator terms, and then I'll try to find the factors. First I'll take x outside, so it will be x into 1 is x, and I'll copy this. Next I'll take x plus 4, so x plus 4 into 1 is x plus 4, so I stop it here. So if I multiply these two, that will become the LCM. So this is the LCM. I don't have to perform all these steps, this is just to explain, right? LCM will be product of these two terms. This one itself will be the LCM. What should I multiply with A so that I get an LCM? Now I should multiply x with something so that I get the LCM. X is already here, right? X is already here. Now I should get this x into x plus 4. So if I multiply x into x plus 4, this will be same as this LCM, right? Correct? But I have to multiply A with x plus 4, numerator. So A with x plus 4. Similarly with B, already x plus 4 is here, right? What is left over? X, right? So I have to multiply with x, but I have to multiply numerator with x, right? Now you notice when I multiply this, I'll get this LCM. When I multiply this, I'll get this LCM, right? Now I'll copy the left hand side. Now the denominators will get cancelled, both are same. I'll be left with 3x plus 20 is equal to a into x plus 4 plus b into x. Now I have to find the values of x, right? I have to get the values of a and b. For that I have to get the values of x. Here it is plus 4, so put minus 4. Here there is nothing, so put x is equal to 0, right? So now I'll substitute at x is equal to minus 4. So I'll get 3 into minus 4 plus 20. I'm substituting here. So a into minus 4 plus 4. One of the terms have to become 0 plus b into minus 4. This will become 0 minus 4b. This will be 20 minus 12, which is 8. Therefore b would be minus 4b is 8 and b is equal to 8 by 4, which is minus 2. So b is equal to minus 2. Now we'll find the value of a. To find the value of a, we'll have to take next value of x. X is equal to 0, right? At x is equal to 0, put x as 0, I'll get 3 into 0 plus 20. I'll get 0 plus 20. What else is here? A into 0 plus 4. A into 0 plus 4 and b will become 0 because b into 0 is 0. So I'll get 4a plus 0 is 20, which means a is 20 by 4, which is 5. A is 5. So I got the value of a, right? Now I'll take this equation, this expression where I had splitted and substitute the value of a and b. I will substitute the value of a. A is 5 by x plus b is minus 2. So I'll put minus 2 here. Minus 2 by x plus 4. So this is the final answer. Now let's take another problem. Similar one, right? We have something like this, x cube minus x. Now again, we can't have cube here. We should express in the form of linear equations. That is, we should have something like x plus 3 or into x like this, right? So what I'll do, I'll take common factor here, right? I can write x cube minus x as, I'll take x as common, right? X is common. X cube is x into x minus x, right? So if you look at the common factor, what is common between both the terms? X is common. So I'll take x as common. Now what does common factor mean? You have to take this x cube, divide by x, then you take minus x, again divide by x, this common factor. So if 1x and 1x will get cancelled, I'll be left with 2x, which is x square. And here x and x will get cancelled. So it will be 1 minus 1. So it will be x square minus 1. Now again, I can't have x square here, right? It should be 1x only, x to the power 1. What do? There is one important formula which you'll have to remember. A square minus b square is equal to a plus b into a minus b. Now here if you observe, I have x square minus 1. I can write it as 1 square, right? If I put 1 square also, it's 1 only, right? Instead of minus 1, I can put minus 1 square. Now this is in this format, right? X square minus 1 square. So as per formula, I have to write it as a plus b into a minus b. A is, instead of a, I have x. And instead of b, I have 1. Let's take this as a, this as b, right? Instead of b, I have 1. Again here, a is x, put minus, instead of b, I have 1. So I have to put it as like this. I have to put x plus 1 into x minus 1. So basically, I can write x plus 3 by x cube minus x as, I can write it as x plus 3 by one thing we took x as common. Instead of x square minus 1, I let x plus 1 into x minus 1. So I have to write it as x plus 1 into x minus 1. So I get 3 terms. Now, since there are 3 denominator terms, I'll have 3 fractions. A, B, C. Right? Add these fractions. One denominator will have x. For this I'll have x plus 1. For this I'll put x minus 1. Now I'll solve this. So if I take LCM, it will be, all these 3 terms will become the LCM. Right? Because all 3 terms are different. LCM will have all different terms. Right? So now what should I multiply with A? What should I multiply with A? Basically, what should I multiply with this denominator x to get this entire expression? I have to get this entire expression here. Here I have only x, right? I have x. What is left out? These x plus 1 and x minus 1. So basically, I have to multiply this with x plus 1 into x minus 1. Only then I'll get this entire expression. But I don't multiply here. I have to multiply with the numerator. So a into this much. X plus 1 into x minus 1. Now, what should I multiply with b? So I already have x plus 1, right? What is left out? X into x minus 1. So I have to multiply x into x minus 1. But I have to multiply with the numerator. So b into x minus 1. Now c. Here. So here I have x minus 1 and x minus 1. What is left out? X and x plus 1. So I'll multiply c with x and x plus 1. Now the denominators will get cancelled because they are same. So I'll be left with, so here's the expression. Now I'll find the values of x because I have to find the value of a, b and c. To find the value of a, b and c, I have to get the values of x. Now here x plus 1. So x will be opposite side, minus 1. Here x is minus 1. So opposite side, plus 1. Here there is nothing. So you take x is equal to 0. Right? Now you have 3 values of x. Let's take at x is equal to minus 1. So at x is equal to minus 1, it will become minus 1 plus 3. This will become 0. Minus 1 plus 1 is 0. Here it will be again minus 1, minus 1, minus 1 plus minus 1. Minus 1 plus 1 is 0. So you'll get minus 1 is minus 2. Minus 2 into minus 1 is plus 2. Plus 2b. 0. 3 minus 1 is 2. Which implies b is equal to 1. So b is equal to 1. Now we'll take the next value of x. At x is equal to, what is the next value? 1. We'll take this 1. So x plus 3. So 1 plus 3 is equal to a into 1 plus 1, and it will be 1 minus 1, which is 0, plus b into 1 minus 1, which is 0, plus c into 1 plus 1. So this will be 4 is equal to, this will become 0, this will also become 0, this is 2, c. So c will be 4 by 2, which is 2. So C is 2. Now we'll take next value. What is next value? We'll take this one, x is equal to 0. So we'll put x is equal to 0 here. So it will be 0 plus 3. This will be a into 0 plus 1 is 1. 0 minus 1 is minus 1. This will become 0. This one also will become 0. So we'll get minus a is equal to 3, which means a is equal to minus 3. I'm just shifting minus here. So a is equal to minus 3. So now we got all three values a, b and c, right? So in this first expression where we had split it into partial fractions, we will substitute values of a, b and c. A is minus 3 by x, b is 1, c is 2. B is 1 and c is 2. So this is the final answer. So we'll take another problem here. Here again you have, first you have to check if it's proper or improper fraction, right? Here the degree of numerator is 1, right? Here when I multiply x square with x, I'll get x cube. So degree is 3. So this is proper fraction, right? This is proper fraction because degree of numerator is less than degree of denominator. Now here again I can't have x square in the denominator. So what I'll do, I can write x square minus 4 as x square minus 2 square, right? And then I can use the formula a square minus b square is equal to a plus b into a minus b. Here instead of a I have x square, instead of b I have 2 square. So I'll write it as x plus 2 into x minus 2. So I'll write this entire expression as x minus 1 to x plus 2 into x minus 2. So this entire thing I'm writing as x plus 2 into x minus 2. Now we'll split it like this. A, 3 terms are there. So a plus b plus c. This is x minus 1 plus x plus 2 plus x minus 2. So if I take the LCM will be all 3 terms. So this will be a into x minus 1 is already there. Remaining terms are x plus 2 into x minus 2. Then I have to multiply b with x plus 2 is already there. I have to multiply with the remaining terms, which is x minus 1 into x minus 2. Then c with remaining terms, x minus 2 is already there. So with the remaining terms, which is x minus 1 into x plus 2. So denominators will get cancelled. So I'll get this expression. Now I'll take the values of x. Plus 2 means minus 2. Here minus 2 means plus 2. Right? Again you have x is equal to minus 1, which means take the opposite sign 1. So take 3 values of x and substitute. At x is equal to minus 2. We'll get minus 2 plus 3. It's equal to, here minus 2 plus 2 will become 0. Here you will get b into minus 2 minus 1, minus 2 minus 2. Here it will become 0, right? Minus 2 plus 2 will be 0. So we'll get minus 3. This will become minus 3. This will become minus 2 minus 2, which is minus 4. 4 into 3 is 12. Minus and plus 12b. 12b is equal to 1, which means b is 1 by 12. b is 1 by 12. Now we'll find at x is equal to 2. Second value. X is equal to 2. This one. So I'll get 2 plus 3. 2 minus 2 will become 0. Here it will be b into 2 minus 1, 2 minus 2. This b also will become 0 here. Right? B also will become 0. Then c into 2 minus 1 into 2 plus 2. So I'll get 4c is equal to 5, which implies c is equal to 5 by 4. So I got the c value. Now I'll go to the next value of x. At x is equal to this one. X is equal to 1. At x is equal to 1, I'll get 1 plus 3 is equal to 1 plus 2, 1 minus 2. A into 1 plus 2, 1 minus 2 plus b into 0 plus c into 0. Right? So b and c will become 0 because 1 minus 1 is 0. 1 minus 1 is 0. So I'll get 3 into minus 1 is 4, which is minus 3a is equal to 4, which implies a is equal to minus 4 by 3. And the final answer would be, what is a? Minus 4 by 3 into x minus 1. B is 1 by 12. 1 by 12 into x plus 2. C is 5 by 4 plus 5 by 4 into x minus 2. So this is the final answer. With this, we've come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.